Now, for those of you in Year 11, I'm going to just do a bit of hand waving to get past doing this. This is working out the derivative of e to the x from first principles. I am not going to attempt to do this here. This is actually from Math Methods, Unit 3, so you will do this in Unit 3. I'm just going to do a bit of hand waving and say the derivative of e to the x is e to the x. If you like, I'll give you a bit of practice with that, because basically from that point on, everything else you can work out using the chain rule. For example, e to the kx, where is it? E to the kx, the derivative becomes k e to the kx. Everything else you can work out from the chain rule. And I'm not really trying to test this here, but you do need to know for what comes next that the derivative of e to the x is e to the x. Now, where does that get us? Well, it gets us to the derivative of log x. And the derivative of log x is 1 over x. Now again, there's a little bit of hand waving here. I'm not going to go back to first principles because this is actually, as the textbook here says, it's actually a math methods thing you'll do at the start of Year 12. But I do want to talk about the derivative of log being 1 over x, because your job in specialist maths at this point is to be able to integrate 1 over x to get log x. So let's have a look here. If y is log x, that means x is e to the power of y, where I am almost always talking about logarithms to base e, the natural logarithm ln. So if y is log x, then x is e to the y. Then dy dx, same trick we saw a couple of videos ago, is 1 over dx dy. Well, wait a minute, dx dy is e to the y. That's what we just learnt. So that's 1 over e to the y. But 1 over e to the y is 1 over x. So the derivative of log x is 1 over x. Now there's a little bit of hand waving involved there, and just trust me, the derivative of log x is 1 over x, provided you're using the natural logarithm, base e. Now there are some tricks here. ln of x, or any logarithm of x, is only defined for positive values of x. So let me show you this graph here that the textbook is showing. This is ln of x, okay? Its derivative, the slope of this graph at any point, is determined by this. Notice the slope is positive everywhere. This graph is always increasing, always. As you get out towards as you get out towards positive x infinity, the gradient gets flatter and flatter and flatter, but never quite gets to 0. It won't stop rising. Now, the derivative of ln x, then, is only part of 1 over x. It's that part of 1 over x where x is positive. The derivative of ln x does not include this bit because ln of x is not defined at negative x's. The domain does not include the negative x's. So, for our purposes here, the important thing is this. The integral, then, of 1 over x must be log x plus a constant. Okay, if the derivative of log x is 1 over x, then the integral of 1 over x is log x plus a constant. But this integral is only defined for x greater than 0. So what are we going to do to fix this problem? Well, let's have a think about what happens with log of negative x. This function, log of negative x, is defined for all negative values of x. And we can work out its derivative using the chain rule. So it becomes 1 over u times negative 1, which becomes negative 1 over negative x, which is also 1 over x. It just happens that x is negative. Which means Therefore, the integral of 1 over x is log of negative x plus c, if x is less than 0. So now I've got a function that says the integral of 1 over x is log x plus c if x is positive, or log negative x plus c if x is negative. But we have a much neater way of writing this, don't we? It's called the absolute value. So, in specialist maths, we will define the integral of 1 over x as log of mod x plus a constant. We do still have to say that x is not equal to 0 because on that graph there was no value where x is 0. It's not defined for x is 0. Log x doesn't exist when x is 0, and 1 over x doesn't exist when x is 0. Finally, it is possible to generalise this one more step. If I put a linear function inside my ln, I've got ln ax plus b. If you apply the chain rule just to log ax plus b, you end up with an a on top from the chain rule, a over ax plus b. So what we want to do is actually integrate this without the a on top. So we're just going to divide by a in our integral. So the integral of 1 over linear function ax plus b is 1 over a times ln mod ax plus b. Don't forget to add your constant. And this only works when the thing inside the log or the thing at the bottom of the fraction here is not equal to 0, which is what this bit's about.